Let's try as a next step to control Pacman. Alright, let's dive into the method that gives Pacman his moves. This is where the magic of navigation happens. Let's break it down step by step. We're overriding a method called process, CMD, key. Why? Because this lets us capture key presses directly, perfect for controlling Pacman's movement. It takes two parameters. Message represents the incoming message about the key press. Key data tells us which key was pressed, like the arrow keys. First, we create a variable new position to store Pacman's potential new position. We initialize it to his current position, which is stored in Pacman position. Think of this as testing the waters before we commit to a move. Next up, the switch statement. This is where we figure out what key the player pressed. If it's up, we decrease new position. Why? Because in our grid, moving up means decreasing the y coordinate. For down, we increase new position. Why? Pacman moves down the maze. If it's left, we decrease new position. X, shifting Pacman to the left. And for right, we increase new position. X, Pacman heads to the right. Each of these updates calculates Pacman's new spot based on the player's input. What happens if the player presses some other random key, like space or escape? Well, we handle that with the default case. Here, we call the base implementation of process CMD key, which simply ignores unsupported keys. This keeps our game focused and responsive. Once we know the new position, it's time to move Pacman. We call move Pacman new position, which handles the actual movement logic. This keeps our method clean and focuses this part solely on handling the key input. Finally, we return true to signal that the key press was successfully processed. This tells the program, yep, we've handled this input, no need for anyone else to worry about it. And there you have it. This method is like Pacman's personal GPS, processing your arrow key inputs and calculating the next move. With this in place, Pacman is no longer stuck, he's ready to explore the maze, dodge ghosts, and eat dots like a pro. So hit those arrow keys and let the adventure begin. Alright, it's time to put Pacman in motion. This method is like the engine behind his moves, making sure the game board stays updated as Pacman chomps his way through the maze. Let's break it down step by step. This method takes one parameter, new position. This tells us where Pacman is about to go next. Our job here? To update the game grid and the visuals on screen to reflect Pacman's move. Simple, but crucial. First up, we need to clear Pacman's current spot. Here, we're telling the grid, hey, Pacman just left this tile, so mark it as empty with a space character. Next, we call update tile for this position to update its appearance on screen. Now, Pacman has officially vacated the premises. Once the old position is cleared, we update Pacman position to the new position. Think of this as physically moving Pacman to his new location on the grid. From here on, this new position is where Pacman now lives. Now that Pacman has moved, we need to mark his presence on the grid. Here, we use the character P to represent Pacman in his shiny new spot. Finally, we call update tile for the new position. This ensures that Pacman's new tile looks correct, whether it's showing Pacman, dots, or an empty space. And just like that, the visuals on the screen now match the logic in our grid. And there you have it, this method keeps Pacman moving seamlessly across the board. It clears his old spot, updates his position, and refreshes the visuals to reflect his new home. With this in place, Pacman is officially ready to chomp his way through the maze, one tile at a time. Let's go, Pacman, those dots won't eat themselves, and that's where he moves. Since every old position of Pacman is overwritten with an empty character, it looks as if he eats the dots and moves on. Cool, isn't it? But I see two problems. First, it always looks like he's looking straight ahead, no matter which way he moves, and the second is that he can also move through walls and there's no boundary for him. Since this is not wanted and also triggers an error, that will be the first thing we want to fix. Let's create another method for this. Alright, this method is the bouncer at the door. It checks if Pacman, or anything, really, is allowed to step onto a specific tile. Let's break it down and see how it works. The job of this method is simple. It takes in new position, which is a point representing the tile Pacman wants to move to. Then, it evaluates whether that tile is walkable, or in other words, if Pacman can legally step onto it. First, we grab the size of the level grid. Here, rows is the number of rows, and cols is the number of columns in our grid. Knowing the grid size helps us validate whether the position is even inside the game board. Next, we check if the new position is outside the grid. The if statement condition ensures that Pacman doesn't wander off the edges of the maze. If the new position is out of bounds, we immediately return false. Translation? Nope, Pacman, you're not going there. If the position is within bounds, it's time to check what's on the tile. Here, we fetch the tile character at the new position. This could represent walls, dots, ghosts, or even special features. This line checks if the tile is one of the following. A dot, Pacman loves these. An empty space, free real estate for Pacman. A ghost, yes, Pacman can move onto a ghost tile. If the tile matches any of these, the method returns true, meaning the tile is walkable. Otherwise, it returns false, meaning it's a no-go. And that's how this method ensures Pacman stays in safe and playable areas. It keeps him inside the maze boundaries and checks if the tile is friendly before allowing the move. Thanks to his walkable, Pacman won't be climbing walls, or flying into the void anytime soon. Let's keep him on track and chasing those dots. This looks better. Pacman can eat the dots but can't go through a wall. But he's still looking in the wrong direction and not where he's going. And of course it's a bit strange that he can eat the ghosts just like that. But one by one, let's improve the movement of our hero first. For this we need another variable to capture the rotation and some other changes. But see for yourself. And don't worry, I'll explain every step later. It is important to me that you understand everything so that you can make changes yourself later. Now let's add some style to Pacman's moves. This section is all about making sure Pacman faces the right direction while munching dots. Let's dive in. As you see, we created already a new variable Pacman rotation angle that we fill with data in this method. We've got a little block of if-else magic here that adjusts Pacman rotation angle. This determines which way Pacman's mouth is pointing, up, down, left, or right, depending on the direction of his movement. And hey, Pacman needs to look cool while gobbling up dots, right? This means Pacman's new position Y is smaller than his current position. Translation? He's moving up. In this case, we set Pacman rotation angle equals 270. Why 270? Think of it like a compass. 270 degrees points Pacman's mouth upwards. Here, Pacman's new position Y is larger than before, which means he's moving down. We set Pacman rotation angle equals 90 because 90 degrees is pointing straight down. It's like Pacman saying, down we go. This means Pacman's new position X is smaller, so he's moving left. Set Pacman rotation angle equals 180, this flips his mouth to face left. He's got his eyes on the dots in that direction. Here, Pacman's new position X is larger, meaning he's moving right. We set Pacman rotation angle equals 0 because that's the default, Pacman's iconic position, facing right and ready to roll. This little logic block is the secret sauce that makes Pacman come alive. It keeps his movement dynamic, his mouth pointing in the direction he's heading, and the gameplay immersive. After all, nobody wants a backward-facing Pacman, he's got to lead with his mouth. And there you have it, a neat rotation mechanic that ensures Pacman's always facing the right way. Whether he's heading up, down, left, or right, he's got his eye, or mouth, on the prize, those tasty little dots. Yum! Now that we have the rotation depending on the running direction, we have to change the Pacman graphic to visualize it. To do this, we extend the generate Pacman image method with a parameter that we can pass later. With this parameter we can rotate Pacman in the desired direction. This only requires a single line of code. Really simple, isn't it? Finally, we just have to make a small change in the update tile method that calls our Pacman image and we're done. Time for a test, I would say. It looks much better now, doesn't it? I'm sure that Pacman feels more comfortable now because he doesn't walk around so stupidly without looking forward anymore, right?